We've talked about how you collect data. Today we're going to talk about what you can do with it after you've collected it. Specifically, we're discussing measures of center. I've been skipping warm-ups, so we're just going for it. So a measure of center, or a measure of central tendency, is a number used to represent the middle of a set of data values. So like kind of the typical data value. If I asked you for the middle, what number would that be? There are three ways that you can represent it, and you probably are familiar with all of them already. So your mean, or your average, is the sum of your data values divided by how many there are. One thing you may not have seen before is it is written as x bar, just x with a little line across the top of it. Your median is the middle number when your data values are written in order. So you could also, depending on if you have an even number of data values in your data set, have to average the two middle values. So if you're looking at this data set, those are in order already. You have, sometimes I cross them off, these two values in the middle. So the median is going to be the average of those data values, so just 2.5. I think somebody taught you to do like peanut butter jelly. I don't know, everybody always tells me that. Your mode of a data set is the number that occurs most often. So you could have a data set that doesn't have a mode, like if there is no number that occurs more than all the rest of them, like this data set that I did up above. You could also have two modes. So say you have 1, 2, 2, 3, 4, 4. Then both 2 and 4 would be modes of your data set. Mode isn't the most useful for talking about measure of center because really it ignores everything except the ones that show up the most often. So let's do a little comparison. So if I have race times for runners in minutes, I'm going to find the mean, median, and mode. So my mean, x bar, is what I get if I add up all those data values, 5 plus 6 plus 6 plus ... plus 11, divided by the number of them that there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So you're going to end up with 75 over 10, or 7.5 minutes for your mean. I like labels. Labels are good. Your median, these are already in order. So if I find the middle data value, back and forth here, it also happens to be, if you average your 7 and 8, 7.5 minutes. There is a symbol for that one. I don't know if you're going to see it or not, but I'll just throw it out there. It's X with a little tilde over in it, kind of like you see in Spanish class. That's a symbol for median. And then your mode is the data value that occurs the most often. So we have 3 6s and 3 8s occurring more than the rest. So 6 and 8 minutes would both be modes of that data set. Your data set might have something called an outlier, which is basically a data value that doesn't seem to fit with the rest. It can be a lot smaller or a lot larger than the rest of your data values. Sometimes it comes from like a measuring error, and sometimes it's just you have a weird result in there. So let's say that you've got this additional runner entering the race with a time of 25 minutes. Somebody's walking this one. So we have all of our original runners plus this walker. We're going to find the mean, median, and mode of that data set with this new runner and see what your outlier does to your measures of center. So I'll just jot down what they are because I'm sure that you could calculate them. You would just add in that 25 and then there are 11 data values. You'd get a mean of approximately 9.09 minutes, a median of 8, and your mode would still be 6 and 8 minutes. So if you look at what impact the outlier had on our measures of central tendency, well, our mode didn't change at all. So it was affected the least. Our mean and our median both were impacted some. Your median went from 7.5 to 8, so it changed by half a minute, and your mean went up by 1.5 minutes. So your mean was impacted the most. And that's actually always going to be true. Your mean is going to be more largely influenced by outliers than your median or your mode. So it's a good idea to use median to represent your set of data values if you have an outlier. It's going to be a better representation than mode. So use the median when you have outliers. When your set has outliers. Okay, so we've got a set of science scores, and we're trying to calculate what score George needs to get in order to get a test average to get on his next test, in order to get a test average of 81. So if you take and think about how you find your average, your mean comes from adding up all your scores and dividing it by your number of tests. So if I add up all my scores, 85 plus 89 plus 83, and so on, plus my mystery test score. Like, I don't know what this last test score is, because I'm taking another test. I know I'm going to try to get a test average of 81, so if you multiply that 81 by 8, you're going to get 648. If you add up those test scores without our missing test score of x, you get 595. And then subtract 595 will get you, George only needs to get a 53 on his next test in order to average an 81, because his previous test scores were pretty decent, and he's only aiming for an 81. Okay, a little baseball. Baseball player averaged .375 home runs per game during the season. And if we played 160 games, we want to find the total number of home runs that the player hit during the season. So if you think about his average, that comes from his total home runs divided by the number of games. We know the average, .375. We know the number of games was 160. So if you multiply .375 times 160 to solve for your total number of home runs, you're going to end up with 60 home runs. I'm not a huge baseball person, so I'm not really sure if that's a lot or if that's just like mediocre. I feel like that's a lot. You can laugh at me and my lack of baseball.